The difference between a stable proxy server and one that crashes under load often comes down to how you manage backend sessions. You'll see exactly how to implement both shared and isolated session strategies in FastMCP 2, including when to reuse connections for performance and when fresh sessions prevent race conditions. The patterns here determine whether your proxy handles concurrent requests safely or becomes a bottleneck.
Hash share session across all requests. Be careful with concurrency. Shared client proxy client. Backend server pi. Def shared session factory. Return shared client. Proxy equals FastMCP proxy. Client factory equals shared session factory. Hash create fresh sessions per request. Recommended. Def fresh session factory. Return proxy client. Backend server pi. Proxy equals FastMCP proxy. Client factory equals fresh session factory.
This demonstrates the session factory pattern for managing backend connections in proxy servers. The concept revolves around delegating session creation to a configurable factory function, rather than hard-coding connection logic. What makes this distinctive is the explicit separation between session lifecycle management and proxy operation, enabling precise control over resource sharing and isolation. The pattern works by treating session creation as a first-class concern. Instead of embedding connection logic within the proxy, you provide a factory that produces sessions on demand. This design enables two critical strategies: shared sessions for performance when safe, or fresh sessions per request for isolation. The proxy remains agnostic to the session strategy, focusing solely on request forwarding. This approach solves the fundamental tension between performance and safety in concurrent systems. Shared sessions reduce overhead but risk context mixing, while fresh sessions prevent interference at the cost of connection latency. The factory pattern lets you choose the right trade-off for your use case, whether you're building a high-throughput gateway or a secure multi-tenant proxy. Let's break it down line by line.
Hash share session across all requests. Be careful with concurrency. Shared client proxy client. Backend server pi.
This creates a single proxy client instance shared across all requests, establishing a persistent connection to the backend server. While this reduces connection overhead, it introduces concurrency risks since the same session handles multiple simultaneous requests. Use this only when you've implemented proper thread safety or for single-threaded scenarios.
Def shared session factory.
This defines a factory function that returns the shared proxy client instance. It enables session reuse across all requests, which improves performance but requires careful concurrency handling. This is the factory pattern for centralized resource management.
Return shared client.
This returns the same shared client instance for every request, creating a persistent session across all proxy calls. This pattern maximizes connection reuse, but risks concurrency issues if the backend isn't thread safe. Use only when you explicitly need shared state between requests.
Proxy equals FastMCP proxy. Client factory equals shared session factory.
This instantiates FastMCP proxy with a shared session factory, forcing all requests to reuse the same backend connection. While this reduces connection overhead, it introduces concurrency risks since the shared session lacks request isolation. Use this only when you've explicitly handled thread safety in the backend.
Hash create fresh sessions per request. Recommended. Def fresh session factory.
This defines a factory function that creates a new proxy client instance per request, eliminating shared state issues. The fresh session per request pattern prevents race conditions and data leaks in concurrent environments. This is the recommended approach for production systems handling multiple simultaneous requests.
Return proxy client, backend server Pi.
Instantiates a new proxy client connected to the backend server. This is the factory function that FastMCP proxy calls to create either shared or isolated client sessions, depending on the concurrency strategy. The string argument specifies the backend server location, establishing the connection target.
Proxy equals FastMCP proxy. Client factory equals fresh session factory.
This instantiates FastMCP proxy with a factory that creates fresh client sessions per request, eliminating shared state issues. The pattern prevents race conditions and memory leaks in concurrent environments by isolating each operation. This is the recommended approach for production systems where request isolation matters. Session management patterns. The client factory parameter in FastMCP proxy gives you explicit control over session creation and reuse, a pattern that balances performance with isolation. Shared sessions across concurrent requests risk context mixing, while fresh sessions per request eliminate interference at the cost of connection overhead. The recommended approach is fresh sessions per request, which provides automatic isolation without additional synchronization code.
The session that never persists handles every request, while the session that persists handles no request twice.